Okay, so I wanted to do another video in response to something a forum member posted about compasses. The forum member is concerned that a X series implant, so one with a little ferrite core like this one, will implant it in this part of their hand, right where they would normally grip something, will impact the performance of a lensatic or sighting compass. So I actually don't have a lensatic compass, but the configuration of this one is kind of similar. It's suspended in liquid, so there's very little friction, and it should perform very similarly. So maybe we can get some information about that. So first off, um, compasses are suspended, and because of the very little amount of force that's needed to unbalance them, and the magnetic material built into the compass, it aligns with magnetic north, the very weak magnetic field that the Earth has present everywhere at all times. So to show what a normal magnet would do, I have a couple different magnets here. So first off, I have this neodymium magnet here. It's pretty small. It's maybe like 5 centimeters or 5 millimeters by 5 millimeters. And I can show you how far away I'm going to be able to influence this compass. So I can, this is the direction of magnetic north. So I'm able to impact the alignment of that compass with a magnet of this size from like a good 10-15 centimeters away. I'm putting this over here far enough away that it's not going to impact the compass, but I have an even more powerful magnet, this one right here. Oh crap. So this one is maybe 3 centimeters tall by 2 centimeters diameter, something like that. And the strength of this magnet is exponentially more than the previous one. So I just moved it about a meter away, so 100 centimeters, and it's no longer affecting the magnet. But as I bring it closer, it begins to affect it at about 50 centimeters. And if I bring it like within sight of the camera, it completely overcomes the Earth magnetic field. So the magnetic field being created by this magnet is tremendous. But if I align it in this direction, the effect is lessened because the poles go this way. So I'm going to put it over on the other side of the table, aligned like that, and you can see the magnet goes back to its normal orientation. So the question of the forum member was, does an X series like this get impacted or impact the performance of a compass held very close by? So there is ferrite inside of here, and ferrite is a very magnetically permeable type of iron, like basically dust compressed into a rod, and it is not inherently magnetic, but the entire point of using it is that it can accept magnetism imposed on it by external fields. And it takes many like hours or days for an introduced field to naturally degrade and this to go back to a bunch of random orientations. So somewhat recently, this has been introduced to some kind of magnetic field, and when I introduce it, it has a very small, barely perceptible effect on the compass. So it is present, but I'm not able to create a significant deflection with it because the domains, which are the regions of magnetic flux inside of here, are kind of random. There's very little net magnetic flux, so the impact is very small. Now this is a compass, but it does have friction at the connection point. So to more thoroughly explore how much you can impact the magnetic field in the surroundings, I'm going to make a compass with a piece of paperclip that I cut, which is steel, and suspended on water, this little foam floater. So this has the same properties. It is magnetic, but not, the magnetic domains inside of it are not concentrated in one direction. But I actually want to do something fun. I have a magnet in my fingertip here. So I can magnetize the tip of this thing and align all of those domains using my magnet itself. So this is potentially another use case for having a magnet implant, is that you have a compass anywhere you go, because you just need a small piece of iron, and then you need to suspend it on some water. So this is the end that's has the magnet in it, and it naturally aligns with magnetic north. So this is the end. And you can see that against the forces of the water, it's able to pretty easily align itself with magnetic north. Like, it definitely wouldn't do that if there wasn't a magnetic field present inside of it. So as a result of that, let me take this X series and diverge this much more sensitive compass. So I am able to affect it, less so than the other compass, honestly, but it's a very minor effect. So yes, confirmed, there are net magnetic moment present inside of an X series, but it's so insignificant, especially with the impact of how much distance there is from the skin, simply, and also just from the distance from your gripping point, that I pretty much doubt you're going to have any measurable effect on the performance of a compass that you hold in your hand. But if you have a magnet implant, you're definitely going to be experiencing some weird behavior with a compass. So be careful with those.